So this is the notes, the first part of the notes for section 4.1, talking about sampling and surveys. In this part of the notes, we will talk about population versus samples. We'll talk about voluntary response and convenience samples and why these are bad. We'll also talk about how to use a random digit table to select a simple random sample. We can use other methods, and we can use our calculators to do this as well, but to check that we're doing it properly, we'll give everybody the same portion of a random digit table, and that way, if you're doing it properly, we'll all get the same result. So we'll use a random digit table in class and on tests, even though in reality you would probably use your calculator or some other technology. Okay, so population and censuses, and then also we're talking about samples here. So population is just everybody or everything, depending on the situation. It could be all of the Coca-Cola bottles filled in the Coca-Cola plant last Thursday, or it could be the population could be all teenagers in the United States. A census is what you collect when you collect data from the entire population. So the United States government attempts to do a census every 10 years, in which they tend to try to count all individuals in the United States. And we use that for allotting money from the federal government. We also use it to decide how many representatives each state is going to have in Congress. But that's not the only kind of census. I mean, if you are checking every member of a population, if I measure the foot length of every senior at Montclair High School, then that's a census, because if we're thinking of every senior in Montclair High School as the population, if I measure everything about, every person or every member of that population, then that's referred to as a census. So it's not just that thing that happens every 10 years by the federal government. A sample is just some sort of subset of the population. So maybe instead of measuring every senior's foot, I just take a sample, randomly select 50 seniors, and I measure their foot. That would be a sample. So a subset, hopefully randomly selected, that sample, and we hope that it is representative of the entire population. So visually, we can see here that we have a population, a subset is the sample. The whole point is that we collect data from that sample, and then we make some kind of inference back to the entire population. So if I ask 50 seniors if they're going to prom, and 40% said yes, they're going to go to prom, then I hope that I could infer back to the population that about 40% of the population of seniors at Montclair High School are going to go to prom. So we know how big of a venue we need, we know how many tickets to print, that kind of thing. All right. We'll often draw conclusions about an entire population based on what we get from the sample, like that example I just talked about. So we want to, first of all, make sure that we know what the population is. So we sort of have to define what the population is that we're talking about. We want to say exactly what it is we're going to measure about that population. And then we will survey a sample of them. And then we want to sort of decide to how we're going to choose the sample. Often in examples, we just say, oh, a random sample was chosen. It's actually a difficult task to find a proper random sample from a population. All right, so let's start with how we do a bad job, how we sample badly. All right, so something called a voluntary response sample. All right, so here's an example. The advice columnist Ann Landers. So Ann Landers was an advice columnist. You may not know what that exactly means. It means newspaper. Columnist is someone who used to write for the newspaper. And so she would, she had an advice column. So she had, every day you'd open the newspaper to a particular section and particular area, and you would read, the advice that Ann Landers is giving people. So people would write in and say, oh, Ann, my boyfriend cheated on me. He did this and he did that. Should I give him another chance, basically? And so Ann Landers would, she would get these letters from people. She would read them, and then she would reproduce the letter in the newspaper and then give her advice. So at some point, Ann Landers decided, and she asked her readers one day in her column, that if you had to do it all over again, would you have children? And basically said, okay, write to me and tell me whether you would have children again if you had the chance to do it all over again. All right, so a few weeks later in her column, it was headlined that 70% of parents said the kids aren't worth it, so they wouldn't do it again. So 70% of the 10,000 letters she got from parents said, oh gosh, if I had to do it again, I wouldn't. All right, so interestingly enough, a statistically valid simple random sample of the population a few months later found that 91% of parents, of course, she's only going to listen to parents, right? Because if you don't have kids, then this question doesn't pertain to you. So she found that 91%, if you took an actual simple random sample or a representative sample, random sample of all parents in the United States, 91% of them said yes, they would do it again. So what's going on here? So according to the population, all right, that she is looking at, so we're talking about parents, so is the first, I guess, sample that she got, the 10,000 letters that got mailed to her, is that a representative sample? So first of all, it wasn't random, right? She didn't choose a list. She didn't go through a list of people and then randomly pick 10,000 of them. Those people chose whether they wanted to participate. And so that introduces bias. And you can see that 70% of them said, oh, heck no, I would not have children if I had to do it again. But if we took a true representative random sample, 91% said yes, they would. So not only is it wrong, it was so vastly wrong in the wrong direction, okay? So in other words, the poll that she took, 30% said that they would do it again, 70% said no, I wouldn't. But in reality, instead of 30% saying that they would do it again, it was really 91% that said they would do it again. So this is something called a voluntary response. So you see this a lot. The news says, here's a poll, call in or tweet your response to us or whatever. So these are not statistically valid polls, and you can't really do anything with the information. Of course, it's interesting and fun to run these things, and they do it a lot on the news, but it's not statistically valid. It really doesn't mean anything, and you can't use this in any statistically valid way. All right, so voluntary response means that someone chose whether they were going to participate. You did not randomly choose them. Now, that's not to say like I get a survey in the mail, right? So a survey company randomly chose me and sends me the survey. I actually choose whether I'm going to mail it back to them, fill it out, mail it back to them. But that's something different than this. This is I choose whether I am part of the sample or not. I am part of, if I get a survey in the mail, somebody chose me as part of a sample. Now, whether I respond or not respond, that's voluntary. That's a under response bias potentially. That's something different than this. This, I wasn't chosen as part of a sample. I decided to write Ann Landers. And so what's wrong with this is that you often get a bigger response from people who have a negative feeling. This is like Yelp, right? So you want to go look at a restaurant, you're going to a restaurant, you go look at Yelp and see what the reviews are, right? But it's not statistically valid, right? Who writes a review on Yelp? More often than not, it's people on the extremes. Either they had a really wonderful experience, or more often than not, they had a really bad experience, right? I go to restaurants quite often, and I never write on Yelp. When do I think to write something on Yelp? Is when I had a bad experience. Oh, I need to warn people that this restaurant is horrible, right? So then I go and I write something on Yelp. So they tend to, the voluntary response samples tend to be, and as you can see here, right, who wrote in to Miss Ann Landers is people who had a horrible experience with their children, right? Oh, my children are in jail, or, my children won't leave the house. They're 35 and they still live with me, right? So they have all these bad experiences, and then those are the people who take the time to write Ann Landers and complain. All right. Another bad type of sampling is something called a convenience sample. So this would be like, oh, I want to know if seniors plan on going to prom. I'm just going to ask all of the students in my AP statistics class, all the seniors in my AP statistics class, I'm going to survey them. Well, that's great if that's a representative sample, but is it, right? So AP statistics students might tend to be a little nerdier than your average student. You guys like math. You're taking an AP math class as a senior, so you might be a little bit nerdier. You may not be dating anybody, and so you may not be a representative sample, in which case that would lead to bias, okay? So here's an example. Bob, president of the freshman class, wants to estimate the number of freshmen who plan on attending the homecoming dance. He asked just the 26 freshman members of his algebra class if they plan to attend the dance. Problem with that is that there may be bias, right? If those 26 freshmen in his algebra class do not represent the larger population of freshmen, then there's going to be bias to it, right? So maybe those students are more likely to attend or less likely than the population. And so you can't do that. What you have to do is you have to do a random sample. You can't just pick people that are convenient. That's called a convenience sample. It introduces bias. All right, how to sample well. First of all, we want a random sampling. And that will ensure, or at least to have a better chance that the sample we get is representative of the entire population. All right, so the simplest type of random sampling is called a simple random sample. And only this one gets abbreviated with SRS. So if you see an SRS, that means simple random sample. We have other sampling methods like stratified random sample. Don't use SRS as an abbreviation for any type of sampling other than simple random sample. All right, so the size of our sample is going to be lowercase n. That denotes the number or size of our sample. And we're going to use a random digit table. And again, we're going to use a random digit table just because that way everyone has the same numbers and everyone should get the same results. If everyone is using their random digit generator on their calculator, everyone would have different results, and I have no way of knowing whether you did it properly. If you look at a random digit table, the first column is not random. You can see that it is numbering the rows, so 101 down to like 150. So, and also you look across, you can see that each row is 5 groups, numbers of 5, numbers in groups of 5 across, and so then there's little gaps in between, and this is just for navigational purposes. So we sort of ignore those gaps between them. So we think of it as what's one continuous stream of numbers. So looking at row 101, for example, it's 1 9 2 2 3 9 5 0 3 4 0 5. We just use the numbers as they are, and if we go to the end of the row and we need more numbers, we just continue right on. So at the end of row 101, we have 8 2 8 5 3 7 3 6 7 6. We just continue on with the next row should we need more numbers. All right, so choosing an SRS with some technology. All right, so first of all, we're going to if you're going to use technology, we randomly take our population and we number everyone. We give them a distinct number, and then we can use our random number generator in our calculators or on a computer to generate n numbers. Remember, small n is the sample size, capital N is the population size. So we would pick small n, different integers from 1 to capital N. All right. Now we're more often than not going to be using our a random digit table. So first we take our population, and we number all of the members of our population, and we use as few digits as possible. And we'll go through an example of what that means, as few digits as possible. So we read consecutive groups of digits of the appropriate length from left to right as we go across the table. We ignore any groups of digits that weren't used as labels for individuals. So if I only have 421 individuals in my population, then I ignore any numbers beyond that. Okay, and then when we have enough labels, we stop. Like when we've picked enough numbers that correspond to how many we need in our sample, we'll stop. All right, and then the sample is just going to be everyone that corresponds to a number that was chosen. Let's go through an example. I think this is probably confusing until we actually do an example. All right, so here we have 28 different hotels, and we want to pick numbers. So you can see 28 is our sample, is our population size, and we want to choose 4 hotels. So we have small n is 4, capital N is 28. Now capital N is 28, it needs 2 digits, right? 2 and an 8, 28. That's 2 digits. So we don't start by numbering them 1, 2, 3. We have to use 2 digits. We have to use 0, 1, 0, 2, 0, 3 to number those. All right, and we're starting on row 130, so I've reproduced that here. And so we look, and so the first number we come across is 69. And so 69 is outside, right? So we kind of break that row up into 2 digits at a time, if you will, right? I mean, we don't rewrite it like this, but this is what we're thinking about. And so the first number is a 69, and that's no good. It's beyond the 28, which is our population size. The next number is 5. And so that is ideal. And so that means the corresponding hotel, Beach Castle, will be part of our sample. Next one is 16, also good. That means number 16, which is the Radisson, will be part of our sample. 48 is too big. It's beyond 28, so we can't use that. 17 is the next one. That's good. So we use Ramada. And then the next one's 87, too big. We're going to ignore that. Notice in this case, now sometimes depending on what we're doing, repeats are okay, but here we can't sample the Ramada twice, so we're going to skip over that one. And actually 17 shows up again, so we're going to ignore that. All the other numbers are too big until finally we get to 20. So the C Club is our last and fourth and last hotel that we need to sample. Okay. And so the number, of course, the numbers 5, 16, 17, and 20 are the ones that we picked from the random digit table, but the corresponding hotels are part of our sample. All right, how could we do this in our calculator? So if we do, if right now everyone takes their calculators and types a 1, a 2, and then hit the store button, and then you want the RAN. So the RAN is gotten by hitting, so first of all, start with a clear home screen. You're going to hit 12, and then you're going to hit the store button, and that gives you a 12 and an arrow. Then you're going to hit the math button, kind of in the top left area of your calculator buttons. Hit math, and then go over to probabilities, which is the PRB. And then you'll notice that one of your options is RAND, which is the first option. So hit that. And then, so on your home screen right now is 12 arrow RAND. So you want to hit enter. Okay, and so it doesn't seem to do anything, but it stores 12 in the random memory spot in your calculator. And so what that does is it seeds our calculator. So everyone's calculators right now should be, their random generator should be in the same location or starting spot. Okay, so now when we use our calculators, we should all get the same result. So even though it's a random digit generator, as you work through this, you're going to see that your results are the same as my results because we've seeded our calculators all to the same spot. Okay, so now what you want to do is on your home screen, type RandInt. So we want to go to math again, go to probability, go down to random integer. So select that. On my calculator, it's number 5. So that paste random in, meaning random integer, into my calculator with a parentheses. And now we want to do 1, and then a comma, and then 28, and then close parentheses and hit return. And so it generates a number 27. Now, you might say, well, wait a minute, how are we all getting the same number? It's because, again, that 12 store ran button, that command that we ran, put everyone's calculators in the same spot. So everyone right now has a calculator with 27 showing. So it randomly picked a number between 1 and 28, and that number was 27. Hit enter, and it will do that same, repeat that same command again. So it does random integer 128 again, and this time we all got 8. And then we would do it again and get 20, and do it again and get 18. Now notice when we ran our random, we generated our numbers with a random digit generator on our calculator. We got 4 different hotels. Actually, I guess 20 got repeated. But that's fine. You're not going to get, every time you run another sample, you pick another 4 random numbers, you're going to get 4 different hotels. So that's fine. It's not like, oh, wait a minute, we got a different sample. We would expect that. All right, so we got 27, 8, 20, and 18. Those are the randomly generated numbers between 1 and 28. And then we would then go and use those 4 corresponding hotels as part of our sample. Maybe we call them with a survey question, or we send those hotels managers a survey to be filled out, something like that. Okay. All right. So your homework on this section is numbers 1, 3, 6, 8, and 12. Those are due next class.